I want to talk about something that doesn't get enough attention in discussions about sun damage: how UV radiation interferes with cellular communication. Cells are not isolated units. They're constantly sending and receiving signals, both within themselves and with neighboring cells. This communication system is essential for maintaining normal function and preventing cancer, and UV light throws a wrench into this entire network. Inside every cell, there's an incredibly complex messaging system. DNA contains the instructions, RNA carries those instructions to where they're needed, and proteins execute the instructions. This is happening constantly, with thousands of different messages being sent and received every second. Cells are also communicating with their neighbors through chemical signals, physical connections, and shared molecules. This allows tissues to coordinate their behavior, maintain structure, and respond appropriately to environmental challenges. When UV radiation hits your skin, it scrambles these communication channels. Let's start with RNA, because this is where some of the most concerning effects occur. UV light can directly damage RNA molecules, which means the messages being carried inside cells become garbled. Imagine trying to follow instructions where random words have been changed or deleted. You might still understand some of it, but you're going to make mistakes. Cells experiencing RNA damage literally misinterpret their own genetic instructions. But it gets more complicated. UV exposure can also alter what's called gene expression, which genes are turned on or off. Genes that should be active might get silenced, and genes that should be silent might get activated. This means cells start producing the wrong proteins at the wrong times. Growth-promoting genes might get turned on when they should be off. Genes that suppress cell division might get turned off when they should be active. The cell loses its ability to regulate its own behavior properly. The communication between cells is also disrupted. Cells use something called gap junctions to directly share small molecules with their neighbors. UV damage can close these junctions, essentially isolating cells from their community. When cells can't communicate with their neighbors, they lose the social controls that normally keep individual cells in check. A cell that's isolated from normal communication can start behaving more selfishly, dividing when it shouldn't, ignoring signals that would normally constrain its growth. There are also signaling pathways that run from the cell surface to the nucleus, allowing cells to respond to their environment. UV radiation can activate some of these pathways inappropriately while blocking others. One particularly important pathway involves a protein called NF-κB, which controls inflammation and immune responses. UV exposure can cause persistent activation of NF-κB, contributing to chronic inflammation and creating an environment that favors abnormal cell survival. The troubling aspect of all this communication disruption is how it creates ripple effects. One miscommunication leads to another, which leads to another. A cell that's not getting the right signals from its neighbors might send out wrong signals of its own, affecting even more cells. You can end up with a whole neighborhood of cells that are no longer coordinating properly. But here's a more hopeful angle. The communication systems in your cells have significant redundancy. There are multiple ways to send the same message, backup pathways that can compensate if one gets disrupted. Light UV exposure that your cells can recover from doesn't cause permanent communication breakdown. It's the chronic, repeated exposure that overwhelms these backup systems and creates lasting dysfunction. This means that protecting yourself consistently gives your cellular communication networks time to recover and maintain their integrity, keeping your cells coordinated and functioning as they should.